Hey, it's Oxi, and in this video we'll be taking a look at modulation in the Oxi One MkII. Now the Oxi One has three different modulation features here. You have your LFOs, you have your mod lanes, and you have an external modulation matrix. Now we'll start by taking a look at the LFOs. So press the LFO button here and you get to this LFO menu. Now you have two LFOs for each sequencer, and you can see all the settings for your LFO on this page here. So to switch between the LFOs, you simply press the page button. You have LFO 2 out of 2, 1 out of 2. We'll stick with 1. I will assume that you know what an LFO is, so we'll simply go through the settings quickly and then show you how this works. Now the wave setting will set your wave shape. So we have things like triangles, squares, sample and hold, other basic wave shapes. And then we have these wave settings here from 1 to 14 that are more complex wave shapes. Now there are graphical depictions of each of the waves in the manual, so check that. Now rate is of course the speed at which the LFO completes one cycle, so you can set it quite slow, 16 bars, or the fastest is 64th note triplets here. Now these are tempo synced, and then you can set it in values of 1 to 128 if you don't want it to be tempo synced. So we'll set this to 1 bar for now. Now amount is the amount of modulation the LFO applies to your destination, so you can set it to off or from 0 to 100 and anywhere in between. Now Retrigger will basically retrigger the envelope, so it will start from the beginning of its cycle every time there's a new note on the grid. So every note trigger will cause the LFO to reset. Now the phase setting can be thought of as setting the starting point of the LFO, or the part of the cycle of the LFO where it begins its cycle. So let's say we have a triangle like this, and we are starting normally from here, and then we set our phase to a higher value, and we are actually starting our phase from here. So instead of rising up, we begin by falling down. Now in the Oxi One, the phase setting is in percentages. Quite often you will see phase as degrees. So you might have a phase of like 90 degrees, 180 degrees, or 360 degrees, or whatever. Now offset will add or subtract a value from the value that is put out by your LFO. So let's say your LFO is putting out a value of 50 at a certain point of its cycle. You add an offset of 10. Now you have 60 at that point of the cycle. And if you add or subtract 10 from the value, you get 40 at that point of the cycle. And it applies to every value output by your LFO. Okay. Now for the destination settings, I will start the sequencer here. I have basic sequence running here, and we will start with the MIDI destinations. Now you can assign your LFO to several different MIDI destinations here. You have your aftertouch, pitch bend, etc. And then you have your CC, your continuous controller or control change numbers here for your MIDI channel from 0 to 127. And in this case I have CC4 set to modulate the filter cutoff on my synthesizer. So I set my external destination to CC4, and we are not hearing any modulation because our amount is off. So I will start to bring up the amount. And now we can hear the modulation here. And then we can change the rate of modulation, make it faster. We go very fast, or very slow, very slow movement. stick with 1 bar for now. And our offset will add to the final value put out by the LFO. So let's say I want my filter to be more open all the time, so I'll add more cutoff. So it won't go as low and it will constantly be higher values. Or if I want this to be more muted, I will simply bring down the offset and we get lower values for the entire LFO. Now Retrigger, as I said, will cause the LFO to reset every time there's a new note message here. So right now we're not really hearing any modulation, it's constantly at a high value. But then we can change the phase. This means that the LFO will start at a different point of its cycle. So right now we are causing it to start at a lower value. We get to 50%. Starting at the bottom, and when we come back up to 100, we are starting at the top again. I'll turn Retrigger off for now and take a look at a couple of different wave shapes here. You have a square, you have a sample and hold. For sample and hold, I like a faster modulation. And you might notice that the LFO is out of sync with the sequence. We can, I haven't found a way to sync the LFO or force it to sync with the sequence, so I will simply stop the sequence and press play again. So now we're getting like a classic sample and hold modulation or filter cutoff. We'll go back to triangle and slower rate here. Now for our internal destinations, we will set this to modulate gate. So now the LFO is changing our gate value. So we get longer and shorter gates as the LFO is running through its cycle. And we can make this more pronounced by making it slower. So you'll notice as the sound is getting brighter, we are also getting a longer gate. And as the sound is getting more muted, we are getting a shorter gate. And that's about it for the LFOs. Quite simple, very powerful of course, and you have 2 per each sequencer. Okay, next we will take a look at the modulation lanes. So press the mod button, we get to this modulation lane menu here. You can see 8 different modulation lanes here. You get 8 per sequencer. So if my math is correct, you have 64 mod lanes in total. So quite a lot of modulation possibilities here. Now these mod lanes are basically pre-assigned. Here you get your mod wheel and your expression here on lanes 1 and 4. And then you have CC numbers on 2, 3, and 5 to 8. Now you can change all of these assignments in the settings. Now when you're looking at this modulation lane here, you can see that the it's not quite a circle, but it's some kind of a shape. The inside is black. That means that the modulation lane is muted. So if you want to actually hear the modulation or have the modulation actually affect the parameter, you need to unmute the modulation lane. Now I have a few different ways to unmute these. You can hold an encoder, the corresponding encoder, and it turns white, and hold again, it turns black again, so it's muted. Or you can hold mute and click the encoder. So you can unmute and mute your modulation lanes. Now, as in all of these sort of menus, you can change between the rows of parameters here by clicking the encoder, and the active mod lane is shown by these little lines next to the symbol, and it's also shown here on the grid. Mod lane 1 is active when you have a purple step here on the bottom row, and let's go for CC8, it's up here. So it's the reverse of these sequencer numbers here. So let's set our modulation lane 4 to affect our CC4 again. So we will go into the settings by pressing page. You can also hold shift and click the encoder to get to the settings. So when you are in the mod lane settings, you have to use the encoder that corresponds to that particular mod lane. So if you, let's say we move this encoder 3 here, we are now getting mod lane 7 here because it's active here. So you have to make sure that you are using the right encoder to change the parameters of that particular mod lane. Now we'll set our mod lane 4 to CC destination 4 here. So now we are again modulating our filter cutoff. Now we also have CC destination 2 here, so we will keep it simple and simply modulate 1 CC for now. Now when your modulation lane is active, you can see here we are on lane 4, 1, 2, 3, 4. We can basically just set modulation values on the grid here, or you can draw a shape however you like to do this. We can do something like this here. And then when you press play, as you notice, we are not getting modulation because it's muted. So unmute, we are getting modulation again. And we'll go back into the settings here. Now 2 CC destinations for each mod lane, or do we use 1 for now? You can set your modulation maximum and minimum values, so you can restrict the amount of modulation here. Let's say we want to set this to 78 maximum and 20 minimum. And it will restrict the values put out by the modulation lane. Now if we set these back to maximum and minimum values, you'll notice that the Oxi remembers our previous modulation values, and we are still outputting the same as the restricted one before. So we can just draw a new modulation curve here. Now modulation offset works just like in the LFO, so it will add or subtract a value from the final value put out by the mod lane. So let's say I want constantly brighter, I will set a positive offset, or constantly more muted sound, I will set a negative offset. We'll set it to 0. Now mod random will add sort of a random signal to your modulation. So you can hear a little bit of like a noisy modulation added to your modulation output. We'll set it to 100. And when you go negative, this is actually bipolar, so plus minus 100. So you get a really sort of a very noisy random modulation here. We'll set that back to 0. Now internal destinations. You have basically 2 internal destinations in addition to the CC destinations for your mod lanes. So you can assign your mod lane to internal destinations in the Oxi One, just like your LFOs. So we'll set this again to gate, and we get gate modulation. And you have your internal amount. You can restrict the amount of modulation, and of course you have offset for your internal modulation as well. And you get two of these, they are identical. I will skip division for now and go into the smooth setting. Now, as you may have guessed, this simply smooths the modulation. It's like a slew limiter. So you have steps on the grid here, but we are getting a smoother modulation than it looks here. So it will simply gradually increase and decrease the value in between the steps. So we can set this to a higher value for a much smoother modulation still, or we can set it to 0 for a stepped modulation. So we'll do this to really make the point here. So you get a really stepped sort of almost like a sample and hold style modulation here. I will set smooth to 15. Now linked means that it is linked to your sequencer. So basically your division and your init and end steps here are linked to the sequencer. So if you change, let's go into our sequencer and change our division to 1/8 and go back to our mod lane, you can see our mod lane is set to division 1/8 as well. And we can set link to no. Then we have individual division and init and end settings for the mod lane. So we can set our mod lane to, let's say, 1/32 notes. So it's moving at a different pace compared to the sequencer. Make it really slow. And we can set our init and end. So you can either go in here and set an end step, or you can hold the end and set it here on the grid. So very similar to setting division and init and end in the sequencer. So now our mod lane is independent from the sequencer. Now if you wanted to sync them, you can hold shift and click or tap stop, which will sync them, and at some point it will sync the mod lane to the sequencer. I'll make the division faster again. Now a few more ways to enter modulation values. You can randomize your mod lane. So hold shift and tap the random button. It will give you a random modulation lane here. So you can also make a really long modulation lane. So 128 steps, just like the sequencers. So we'll make it a 128 step modulation lane and hold shift and press random, and we get a very long randomized modulation lane. And press play, and you can see our modulation lane running through the whole 128 steps. You can clear your mod lane by shift and clear. Now another way to enter modulation values is to record them. So you can simply engage record, press play, and if you have set a count in, you get the count in, and then we can move the knob here to record our modulation. I find the recording a little bit fiddly, so I don't really use that. You can also use some external MIDI to record. Just have to make sure that it's corresponding to your mod lane settings. So that's another way to enter modulation values. Now the last modulation feature here is the external mod matrix. Okay, now via the magic of moving things around, we now have a wider view of my setup, so I can show you external modulation with the Oxi One MkII. Okay, now to get to the external mod matrix, you hold Shift and tap Mod. Now you can see your CV in 1 and 2, as well as 16 MIDI mappings here. I will start with the CV in. Now you can see a reading here on the CV in 1. That's going from 0.0 to 4.9 volts. That is an LFO from mutable stages running into an attenuator, and from the attenuator into a CV in on the Oxi. Now the CV ins 1 and 2 on the Oxi are both on the same TRS input here next to the HDMI. So I basically have a TRS 3.5mm cable here that breaks out into two 3.5mm inputs on the other end. So I can plug a 3.5mm TS cable from my Eurorack into either CV in 1 or 2. Now the Oxi can basically handle CV or control voltages from -3 to +5 volts. Now for MIDI modulation, it will only use the 0 to 5 volts. So negative values are clipped, so anything below 0 will not be modulating via MIDI, or it will all be clipped at 0, and anything over 5 volts will also be clipped. So the only usable range is basically 0 to 5 volts. The exception is pitch bend, which can also be modulated with negative CV values, but the Oxi for some reason is basically has asymmetrical negative and positive voltages, so -3 to +5, which kind of makes it so I have to take that into account. Now you can see the reading here, 0 to 4.9. We're at a good range here for MIDI modulation, and we will click the encoder to get to the settings here. Now you can choose a destination for your CC, so the voltage will be converted to MIDI into CC values, and we will set a destination here for our CC4, which is the filter cutoff again, and press play. And we are getting modulation here. Super simple. Now the CC amount can be set to from 0 to, or actually from -200 to +200, so we can make it much more pronounced here. Setting it to 200, we can make it negative. You can barely hear anything, so we'll keep it at +100 here, like this. And basically the CV modulation allows you to take very complex modulation from your Eurorack and bring it into the Oxi, convert it into MIDI, and use it to modulate MIDI destinations. So I will adjust my LFO here on stages. We'll make it quite fast here. So the Oxi can handle quite fast CV to MIDI conversions here. And of course you can just put out whatever wave shape you like. The square. So this can make for some really interesting modulation there. Now, in addition to CC destinations, you have internal destinations, and you have 2 CC destinations and 2 internal destinations for each CV in. So we'll set the internal destination again to gate, which is our favorite, of course. So very easy to hear what is happening. And we'll make this one the amount, the 55%. Get a little bit less modulation on the internal parameter. So that's about it for CV modulation here. You basically convert CV to MIDI and use that to modulate MIDI parameters. So now we'll move on to the MIDI mappings here. So as I said, we have 16 per each sequencer. We'll start with mapping 1. So here you can set your MIDI message type. You can set the CC, your number. Now this is the one that you are bringing into the Oxi. So so if you have an external controller, just set the same settings here as you have sending from the external controller. So we'll just put this to 21 and MIDI in channel would be 1 to match my controller here, this knob right here. An easier way to set this is to use the learn function. So we can click on the learn here and then move our knob here. We can move another knob, it doesn't matter. It will remember the last message it received. So there's channel 1 CC21 and click, and now it is assigned. So that's the easiest way to assign an external MIDI controller to a MIDI mapping here. Now track allows you to select which track of a multitrack or a matricial sequencer this mapping will affect, so it's not applicable here. Now CC out will choose which CC number the external controller will affect. So we will again choose CC4. Now our CC21 on channel 1 here is affecting CC4 on channel 2 here. Okay, so now when I press play, we should be getting filter cutoff modulation on this knob here. Okay, let's go through the other settings here. We have a combined amount and offset for the CC out and internal destination 1. Now, for some reason they are combined here. Then you get internal destination 1 and 2, and separate amount and offset settings for internal destination 2. So let's set this internal destination to our favorite gate. And now we get gate modulation here as we turn the knob and turn this off again. Now parameter destinations, we get 2 of them with amount and offset. We can set these to different internal parameters in the Oxi. There's sequencer enable, sequencer mute, division. Actually set this to sequencer mute, and when we bring this down, you will notice that the sequencer turns white here and it's muted. And when we bring it back up, it's unmuted again. So you can use this to externally or unmute and mute your sequencers with an external controller. And turn that off again. So different destinations there. Now consume means that when it's set to yes, this message will stop here in this MIDI mapping. It won't pass along. So I will show you shortly what this means. And then you have your copy map. You can copy your mapping here. You can paste a map and you can clear the whole map here, and you can see your last value that was sent from the external controller. Now for this consume setting, let's say I will go into MIDI mapping 2 and learn the same controller from the external controller here. And let's say I want to assign this to CC5 here. Now CC5 is assigned to resonance on my synthesizer. So we have CC internal amount 1 at 100%. We have the same controller here assigned and to CC5. So when I turn this, we should be getting increasing resonance as the value increases, but we are getting nothing because MIDI map 1 is consuming the message. Now when we turn this consume message to no, so turn it off, now the message passes from 1 to 2. So we are getting resonance modulation as well as cutoff modulation here. So you can basically build these sort of macro controllers using the MIDI mappings. So right now I have simple macro that is controlling both filter cutoff and filter resonance. And again, if I set this MIDI map 1 back to consume the message, we are not getting any resonance modulation there. But now we get the modulation again. You can hear the resonance because it was high when I turned the consume on. But it doesn't affect the resonance anymore when you have this consuming the message. So basically it just swallows the message whole and doesn't allow it to pass to the next one. Okay, so I think that's it for the external mod matrix. It's extremely powerful. You can build macro controllers, you can modulate a whole bunch of different things using CV or MIDI. I really like CV, even with the limitations in the Oxi. I think that's it for the modulation here. This is probably going to be a very long video. And thank you very much for sticking around. And if you like the video, please like and subscribe, and I will see you again soon.